Hey, everybody. This is Larry. This is day 2 of the March Leetcode Daily Challenge. Welcome. Hope y'all are having a great day. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Set mismatch. Uh, my setup is a little bit different today. Not feeling super well. So, yeah. Um, Let me know if the voice is good. But anyway, okay, set mismatch. So I do these live, so if it's a little bit slow, just fast forward or something. But yeah, you have S, one to N, one of the duplicate to another number. Hmm. Okay. So I mean, I think the standard way, and if I did this in a competition or something like that, I would definitely just create a set, and then it becomes very obvious what the number is, and you just do some for loops and for statements. Um, but I'm trying to think whether I can do this better. Um, hmm. Uh, These are not necessarily in the same order, so that's a little bit tricky. Now, I think the biggest thing I'm trying to see if I could take advantage of is using the fact that it contains all the numbers from 1 to n, so that you know the sum, right? Because basically my idea, thing is that 1 plus 2 plus dot 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 plus n is equal to, what is it? N times n plus 1 over 2 or something like that, or n minus 1 maybe. I always confuse those. Well, yeah, it depends on which one you're talking about, but 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 is that good enough for us to figure out, you know, the answer, right? Like, so we know that the sum is this, and then we know that the sum of nums is going to be some number that's this. Don't know what I was googling, but so it's going to be this minus remove number plus an addition number, right? But we don't. And then the question is whether we can figure it out from all, if this is sufficient to figure out, right? I don't know that. I don't think that we can because we have two variables and one equation. Um, so so obviously also that if we do the set algorithm, right, it's going to be linear time, linear space. So I know this, and we can prove this later if that's what the path that I end up going. But knowing this, my optimization is try to figure out if I could do an O of one space. That's basically what something like this would enable us to do. I don't think that we can, right? I mean, we could take even these examples. Let's say we have one. I don't know. I mean, we could play around these examples at least to begin with. So let's say we have 6, and let's say we convert this to 3. Yeah, let's just say 2 plus 2 plus 3, right? So now we have 7. Can we figure out what's removed? Well, we know that our input array will be 1 more than the optimal, but that could mean anything, right? Because that could mean, because the other thing is that this could be a possibility as well, right? Um, and because we have these two possibilities, um, I don't think that's possible. Therefore, yeah, I don't think it's possible. And of course, you can do it in all one space. You just sort the array, but you know, and depending on how you want to count it, because you could see that the balance is 10 to the fourth. You could do some quote unquote linear things or constant space things because constant is 10 to the fourth. But I think that's a crappy way of doing it. So I'm not going to or count it as all one. Though maybe it's worth bringing it up, but I don't think that's a legit thing. So yeah, but because of this reason, I don't think that we can do this in all one space. I'm just going to do it the naive way. Um, yeah, okay. And the naive way is just we have a set of scene is equal to C. So then now we could have duplicate is equal to none, say. So that because that's going to be our answer, and if for x in names, if x in scene, then duplicate is equal to duplicate is equal to x, else else scene dot add x. So this will get us our duplicate, and then now there are a couple of ways you can do it to get the other number. Now we have a way to get the other number, right? Because we just do the same thing that we were talking about earlier. So yeah. So this is not seen. We add this to x, and then now then the answer will be as we said. Um, which one is the first number? The first. Okay, so the first number is the one that's duplicate, so that's x. Or that's duplicate, sorry. And then the other one is total. As we said, it's going to be total minus n times n plus 1 over 2. And this is the formula that you should probably be familiar with, just because it comes up a lot. Hopefully you do. Well, apparently I did the math wrong, but that's fine. This is an easy fix, relatively, I think. Yeah, because total is missing a number, right? So this is clearly wrong. It's just that I kind of did it very quickly. I wasn't thinking about it because it's a little bit later in the day. Cool. So this looks good. Let's give a nice submit. So this is going to be linear time, linear space, linear time because this for loop is going to be O of n, and space because set is going to be O of n as well. I'm going to see if I look at the solution, see if there's a better solution because I am curious if there's an O of 1 solution. So let's see this together. Brute force, yes, yes. Well, okay, brute force the way of n squared is a little bit too brute force. Better brute force is, okay, I don't know what the better brute force is, but still n squared, so that's not what I'm talking about. We talked about sorting, which is n log n. Sorting takes, log n space. I guess it depends on which sort you like, because I think heap sort isn't, right? For example, that's a little bit, I don't know. Either way, using a map, which is what we did, using an extra array, which is, and we could have done that, taking advantage that we times as 4, but constant space, that's the one that we're looking at. And okay. Oh, it's a constant extra space by, I mean, I knew the solution actually, but I keep on forgetting about it because I don't, oh, and then there's an XOR one, what? XOR one might be pretty cool actually. You iterate the array 5 times, that's ridiculous. I know how to do that one as well, but I'm not going to explain it that much because I don't think that comes into play at all. But the idea is just basically having a state machine, if you want to call it that, of each bit, and then try to find out what the duplicate number is, and then you could do it again. Um, and then you could either do the other like what we did to get the other number, or there's a couple of ways to get the other number once you have the number. And then this one is just a way. Actually, this idea is pretty cool. It's just I don't think about it enough because I don't usually generate in place algorithms because I think it doesn't really make sense to modify the input array. Your customers would not be happy if you're like imagine someone just calls an array to find these two numbers and then the entire array is messed up, right? So I didn't really think of it that way, though in theory, if they if they suggest that we can use it in place, then we can definitely do it. And the idea behind that is that you have these cycles and then you have these permutation cycle. So you put everything into the right place in linear time. I'm not gonna get into that much. But if you really want to Google it, just Google permutation cycle. But one number will be out of place and one number will be missing, and then you could do that all of n times in more of one space. But of course, that modifies the input array, which is really bad design for a function unless it is very obvious and specific that um, manipulating the input is the function. Like sorting, for example, you're like, okay, you want to sort the array. Obviously, it's okay to sort the input, but for this one, your callers may be like, what is going on? Why are all my numbers in a weird place now? You know, so that's not really an answer that I considered for that reason. But yeah, that's all I have for today. Let me know what you think. I know this is a little bit of a weird one, but I'm also a little bit, you know, um, yeah, I don't know. Anyway, hope y'all have a good day. Take care of yourself, and I will see you tomorrow. Bye bye.